Okay, good morning. So today is the due date for homework 4, and homework 5 is due right after Thanksgiving, by the Monday after Thanksgiving. What I'm going to do today after class is going back to academic search, just try to make sure everybody still needs help for homework 4. We will take care of that. If anybody wants to meet for final project, we will talk, and also homework 5. Anybody want to do that? All right, so I'm going to continue. This is what we did last time. We talked about a few concepts. One is template. How do we specify a function template? And the second thing we did was to look at how to specify a function pointer. That's the yellow in the middle. And the third one, what we covered was lambda expression. How do we specify a nameless function? And at the end of the class, what I showed last lecture, was how to combine the three concepts together. For example, we can define a lambda expression and then put in a variable, pretty much like a function pointer, but it's more flexible. And then use that lambda expression as an input argument to a template. So which means that we potentially can define a function template, which is so powerful that we can change its behavior the way we want, depending on what kind of lambda expression we want to put it in. All right, so I need to clarify that all the three concepts is essentially the compiler concept. So lambda expression is a compiler concept, not a runtime concept, because you cannot at runtime input a lambda expression. You have to actually let compiler to generate the code. So pretty much what compiler was doing is translate that lambda expression into a function pointer and just basically put that function pointer as a argument. That's actually in the implementation. All right. So one of the things that leads to here is if you notice that what we call template, the argument part of the template, which is, so how do you know it's actually a template? How do you know you're using a template? Because you saw the smaller sign and the greater sign. Because over here, you're actually putting what are the type you're going to put in. So the template you already start using was a vector. If you remember how you use vector, there's a smaller sign and greater than sign. Within that pair of bracket, you put the type. So for example, reactions star. I actually put in the reference implementation, a vector of reactions is actually a std colon vector, which is actually the name of the template. And then we use a reaction star, which means that that is the type. It's going to fit in that area. So you have been already using that. So now you know what that smaller sign and the greater sign, that's actually the parameter we're talking about here. So I actually want to talk very briefly about the standard template library. And the way I'm going to present, I'll just tell you what's available out there. And then we're going to look at homework 6 and homework 7, because I would like to introduce those concepts deeper within the real code, especially when we talk about math. This is the other thing. So essentially, if you look at a typical C++ standard template library, there is actually a flow chart for you to decide what kind of template you should be using to deal with your system. For example, if you look at all the rectangle box is represent a template, a standard template that offered by C++ library. For example, map is here, vector is here, you have a DQ, you have a list, you have queue, you have priority queue, you have stack. This is pretty much all the standard data structure that you might want to use in a typical application that they provide all of this. So, I mean, I said there was a flow chart. It's actually pretty, if you actually satisfy all the green, basically the green path is leading you, if all this condition is actually derived as yes or no, the answer, then it's going to be using vector. So let's see what they actually recommend. So the first one is that it is order important. If its order is yes, important, you need last in, first out, no. And first in, first out, no. Largest element, first out, no. If all this out, sorted by key, yes, that means the index. And then insert in the middle, you don't have to, no. And then insert at the front, no. And then need to find the nth element, yes. And then size will vary widely, no. And then you actually use vector. You're kind of following this questionnaire, and you can actually decide what will be the most popular template you will be using. And hopefully in your, after you finish this class, when you go out to do that, you'll have the opportunity to try many of them. Then you gradually can decide what will be the best for your the usage of the template. And then the other one is map. Those two we're going to cover in this class. And you can see that you need to find element by key, and then go over there, sort it by key, allow duplicates, no, and then store key to separate value. That's actually important because I mean, we talk about start to seeing the key is being used heavily over here. So for example, JSON is a key value pair, and then we need to search for the keyword for when you build a search engine, for example. And over there, you actually use a data structure called map. Okay, so that is essentially what is the, I'm just showing you what's available as a standard template and what's the logical process for you to decide, recommended by some of the people in the community to decide what you want to do. Either, this is sometimes we call either a sequence container or associated container. Sequence containers, there is a order over there, and then associated containers are looking for using keyword, try to grab it. Okay. All right, having said that, I'm actually going to start talking about your homework 6, but I'm going to start talking about another slide. Sorry. Oh, not this one. Let me just grab. Let me just use my code to actually directly talk about this. Okay, so for homework assignment number 6, so this is homework 5 because I was actually called that homework assignment number 5. If you remember your homework 5, I was called homework assignment number 4, part 3 in previous quarter. So this is actually going to be your homework assignment number 6. So the main idea about homework assignment number 6 is doing something we call JDom. So what's the difference? You remember homework 5, DOM-J is trying to convert the C++ object to a JSON representation of the same object. So now we're going to take that JSON representation and shuffle it back into the C++ world. So let me actually tell you that what is the input looks like. The input will look like this. So this is the example I have been showing you all the time. And of course, it looks pretty horrible if you look at this way. It has all the comment, but I'm actually going to use a to-style string to print it. So if I use to-style string to print it, it will be looks like this. So this is the same JSON, but I'm going to print it this way. So now it's a lot nicer because to-style string, it actually put the things into this kind of nice structured format representation with the tabbing, which show each of the sector. So the first sector is actually action. Action is a key value pair, is an array. This is, by the way, a post that I showed you earlier as an example. And then you have comments. You can see that now I have two comments. That was the part you're handling in homework assignment number 5. So it has the comment, has the created time, has a from, has ID, has a message, has a reaction. And then the reaction has whatever it has. The created time, from again, the type, and things like that. Okay, and then this is basically all structure, and this is another one for the post. It has a created time, it has a from, it has an ID, has some link if you want to publish. And this is a primary message and a reaction to the primary message, and then which one you're sending to, and then at the end there was an update time about when was the last time you actually update this particular post. So that is essentially a structured way of representing. It's just, in fact, nothing magic. I'm just printing a JSON value using to-style string. So that if you ask me what is to-style string, this is an example from a really compact representation like this to the way I showed. So what I'm saying is what JDom is doing is turning this, go back to the C++ object representation. It's the other way around. So actually, let me show you the test driver for this code, what it does. So in homework assignment number 6, we have 2 test drivers. One is actually to just, I'll just show you the program because it's probably easier to just say, what is HW5 produce? So this part, you can see that this is a driver program. What it does is it fopen. So you basically take one input, which I actually used it earlier, just that JSON file as my input. So what I did is I open this file, I take that in, and then I basically, this part of code you should be familiar with when you saw homework assignment number 3 in the HW3 server.cpp. This part of code is essentially take a string, which is the file. I read that string from that file and turn that into JSON value using in the middle of this code called parse. Read parse. This part is actually changing from a string format to the JSON format. All right, so string to the JSON, that's what you did. Homework assignment number 3, server.cpp, you need to send it back the result. You need to use that piece of code for you to do that. This is exactly the same piece. Okay, if parses successfully, now this is what I did. What I did is this part of the code is just the test drive for homework assignment number 3. So essentially you create an object called post. We create an object. By the way, what is a post? It will be given to you. A post contains comments, reaction, from, and all this field. So you author, so you know it's representing the whole social media interaction. It's called a post. So I create a post, and that post is essentially an empty post. nothing in there. It's just empty. You think about it as an empty post. It's over there. And then what you did is this one. You see that what I did is post JDom. So what is my message? My V message? It was generated from this line. You see that this is actually the my V message that was taken the file input and turn that into a real JSON value object. So that is a JSON object. So I'm actually put that JSON object into the input argument of JDom. And then my post is going to process that and give me a result flag to see if that's successful. But now it's different, is that my post was an empty one. Now that my post should have some content. So the test driver is pretty simple. The first one is actually doing JDom. And then after I have that as my post, you see, I'm actually just called dump J again. So here I dump in, here I dump out, and then print it as my style string. So these two should be identical. Means that the input file, the content, you turn into a JSON, you throw it into an object called my post, and then you dump J from that my post. You actually get another output string. And these two strings should represent exactly the same JSON. That actually means that you can have a bidirectional conversion over there. Okay, so let me show you an example how it might work. So let me actually first produce this one. Remember, I run this program. HW5 produce base input JSON. I run this program, I'm actually going to get this representation. I'm actually going to save it this time. I'm going to save it called xyz.json. Okay, so what is xyz.json? xyz.json looks like this. Okay, so this is the JSON string I just produced. Okay, now I'm going to do this. I'm going to run xyz.json. I'm going to take that I just generate as the input for my program. And then I'm going to turn this into xyz, JDom, and then dump J. Okay, you see that I'm actually go through that program, parse it, convert to post object, and then output using to style string. I'm actually getting a XYZ JDom. If this is correct, these two functions, these two outputs should be exactly the same. Yeah, there is no difference between those two. So that means that this program, it convert and convert it back. They actually do the right thing. So that is the function called JDom is doing. I'm going to show you some example about JDom, and then you will see. But before I do that, I want to show you a second test drive. The second test drive. So I have a two test program. The first test program provided to you, I just showed to you, is called HW. It will call HW6 produce .cpp, which is doing just like this. You read a file, you do JDom and do dump J, and then get an output file. This is equivalent to the original one. Okay, that's the number one. But in social media, we have another important function called merge. So for example, I have a post here. What happened? So this is a base. I show you this is a base JSON. Looks like. The base input looks like this. But now I have update. What do I mean by update? You have a post over there, and somebody actually read it, add either 2 extra comment or 2 extra reaction. So let me actually show you the update. So I have update 1. I have 2 updates actually, but I want to show you the first update. The first update, it looks like this. Well, I'm sorry, it's hard to read, but now I'm going to use my program to make it looks nice. This is update 1, input revise, JSON, and more. Okay, now I have the modification. I'm sorry, the structure nicely presented JSON represent the update. So what's the update? The update actually say it's a new comments. There's a new comment over there. There's a created time, and again, there's a from, there's ID, there's a message, but there is something interesting here. Of course, it has a reaction. Over here is a one comment and one reaction. But it has this one. This one is called tagging. This is called tagging. And the tagging is essentially, I'm actually trying to tag somebody. So you can see that I'm actually have a tag. So over here, and the tag for Peter is actually tagging this one. And I can tag a comment as well. It's a comment ID. You can provide a lot of comment tag, but then there is an ID at the end to represent what is the post ID that's actually related to this particular post. So this is something we call update. An update is an additional element to showing the development of a particular social media. And as you can imagine, that this is actually very important because we want to continuously expand our discussion to include everything. And I don't want to look at a huge 20 gigabyte, one single post to do that. I want to actually just look at part of it. And as an update, looks like this. Okay, so the second test program is called HW6 merge. So how do I actually be able to merge these two posts together? Okay, by the way, this actually becomes really difficult if you want to do merge in JSON. If I give you two JSON, how you're going to merge? If I give you this two JSON, this is a JSON number 1, and this is the JSON, the base JSON. And I want you to merge the comments I just have into that JSON. How will you do that? If you don't do JDom stuff, how do you actually merge that? In fact, JSON does not provide you any semantic meaning to the representation itself. JSON is a syntactic representation of an object-oriented model, but without any semantics. So JSON doesn't know this, what does ID means, what is comment means, what is the reaction means. But your program in the C++ world actually knows about that. So that's why this is a very important test cases for you to be able to bridge the world to actually see how the missing part of the semantic from the JSON world, you can actually add it to that in your C++ object. So let me actually show you the driver first, so you will know what's going on. So let me actually show you the HW5 merge. This driver is also provided to you. So now you have this the same driver, but now you look at, I'm actually reading two files. So I'm reading argument 1 is one file, argument 2 is file. So one is JSON file 1, one is JSON file 2. So I showed you two JSON, each of them represented as a file. So I'm actually having two files, put it there. So after I've done that, am I still doing the same thing? Over here, I'm still parsing the first JSON using the JSON reader parse. And then I still have this, my post here. And look at what I did. I just do my post, JDom of the message. And my V message, by the way, represents the first JSON file. So essentially, so far at this point, I'm doing exactly the same thing, what I was doing in the previous test program, HW5 produced. But now I have a second file to handle. Okay, so the second file to handle is starting here. By the way, this code will be given to you with this comment. So you will see that, okay, first JSON done, let's get to the second one. So this is the second one. So what I did is I did this part again. You see that this part of the code is showing again and again. I actually parsed the second JSON file pointer into my V message again. So I'm actually producing another JSON value object from the second file that's input. And what I did here, after I have that, well, here is something which is JSON didn't tell me. I'm actually going to check whether the post ID is the same. Because it doesn't make sense if I try to merge a post and the post update while the post ID didn't match. So I want to merge when they're actually referring to the same post. So that is actually very important, is that information is nowhere will show you syntactically in JSON. That's a semantic information about how to interpret the information. So that's why here I'm actually checking this segment of the code is essentially allow me to check whether the first part, let me just show you the. So if you remember the base JSON, the first one is ID field. That means the post ID is this portion. That's the post ID. And now let me create another window. If I do update 1, and you see that the first element is also ID over here. So each of the JSON has the ID represent the post ID. If I want to merge, then the first thing I'm going to check whether these two ID actually match. If they match, then I'm trying to merge. Okay, so that is what happened here in this part of the code. After you check the ID is indeed match, then it's very interesting. I just actually call JDom again. I just call JDom with the new element, the second element, and it's done. So essentially what I'm saying is the merge is really doing is take the first one, dump it into C++, and then check the second one whether they're the same ID with the first one. If it is, I do call JDom again on the same object my post. So the difference with the first statement and this second statement is when you do the first statement, the my post is empty when you dump in the first JSON. But when you do this the second time, the my post already have all the elements, C++ element in there already. So essentially, you just do a JDom, input the additional update into that. And after you've done that, magically, everything will be actually merged if you implement JDom, correct? Okay, so I'm actually giving you a high-level idea of what JDom is going to do before I actually show you the code to do that. Any question at this moment? High level, just high level? Okay. Having done that, let's actually look at one of the example. Let's see which example I want to use. Let's use a comment.cpp. That's you actually familiar with this very much. Okay, so you're familiar with the JDom, but now let's go to, so you're familiar with DOM.J, so let's go to JDom. Okay, so this is a comment for, I'm actually just trying to finish this. I will go slow on this one because it's very helpful for you to actually understand this part of the code about a JDom function for a comment. And it's actually going to be pretty similar. Just like DOM.J is a recursive call, JDom is also a recursive call. So let me actually go through this very quick, slowly. So as I told you that JSON is a really powerful way to represent information. But the thing is that there is no guarantee that all the information will be there already. I mean, a C++ object that you know, the compiler already checked everything. But when you receive a JSON object, The only thing that's actually guaranteed is that you actually put double quote correctly. You put bracket, curly bracket, or comma correctly. It's basically just checking that simple syntax, which means that you're going to have a lot of missing field. You will have a lot of mismatch in type. You're actually going to have some kind of thing which is totally unexpected. That's what you need to, as a programmer, you need to deal with this and then extract those information, provide check. So I actually put a lot of check in this code to just show you that a typical a code, when you handle JSON, even with the JSON CPP library, you still need to perform all the check in order to make sure your program is still running correctly. So let's actually take a look at this section by section. The first section I'm actually check is that whether this particular JSON pointer is null or not. If the pointer is null, let's just look at this 3 line. I actually check 3 things in this order. In fact, it has to be in that order. If it's not in the order, I might be in trouble. So the first thing I check is whether that pointer is null. If it's a pointer is null, you shouldn't even perform the next 2 checks because it's going to causing segmentation violation. So first I check whether the pointer is null. If it is not null, then I'm going to call is null because sometimes it's a JSON that is a pointer is not null, but the JSON itself is contain nothing. So the JSON value could be itself is a null. So the JSON value could be a JSON object, could be the basic type, and could be null as well. So that's why you want to check whether that's null. If it's not null, you will continue. But the third thing is important is whether this is an object. Because I actually want to make sure that JSON value for doing the rest of this process, it should be a JSON object itself already. That's why I'm checking whether it's object or not. So this recheck is important. It's not null, and it is indeed a JSON object. Then I'm going to continue. Okay, after I've done that, I'm actually going to check the first part is all the element, whether they have all this element. So I'm actually assuming a comment have all this element already. So that's the element you pretty much should be somewhat familiar with from your homework assignment number 5. Whether it has ID, whether it's a from, whether it has a message, has created time, those 4 things: ID, from, message, created time. And then you want to check whether the type is actually what you expected. For example, the ID should be a string. The from should be an object because it's a person object. And message is a string and created time is a string. So basically I check that. If that's actually okay, then I will continue. But this is the part that's actually going to check this one. This one is just for me to create the profile ID and the post ID and comment ID. So this part, I'm actually check whether the comment already have this 3 field. If they already have it, I'm not going to change it. Why is that? Because merge. Remember the 2 cases. One is this is a fresh comment or fresh post. I have nothing, then I need to do this. But this comment already exists. It should have those 3 elements. So essentially, very important here is that we actually check whether this is a fresh or this is a merge action we need to perform. So we need to check that. And then the next one, I'm actually going to do the author part. So again, you see that I always check whether the author is a null or not. If it's a null, I know this is the new author. I need to do that. But if it's not null, I'm not going to update. So the author is basically depending on whether you're doing merge or you're doing produce. So you can see that, okay, now assuming this is a null, what I did is that, okay, I have an author, and what I did is this author JDom to the input JSON pointer from. So essentially I put that from portion of the JSON object. By the way, from is an object. As you can see, I actually check. I check that the from is null, is true, is not true, of course, and the from need to be an object. If it's not object, I will not proceed in processing the JDom. So now I'm actually coming here. The author, you can see that I'm actually, this is within the JDom of comment. And then I'm actually check that, okay, you don't have author at this point. I'm going to actually JDom the author portion into that. Because that will take care of the case for both it's a fresh author or it's actually merge author. In that case, I'm not going to change your author. So essentially, this merge, assuming that if you merge successfully, the comment author is not going to be changed, okay? Any question at this moment? What does that sound? Okay, similarly, you have a created type, you have a message, that's the same way. So now this is the part I really want to get into for the rest of the lecture, is how do you actually handle the reaction? The reaction and tag, remember we have the new thing is called tag. Tag and reaction are very similar, but it is actually very powerful if you can handle reaction and tag. You essentially can do everything that today's modern social media system is doing. So reaction, I'm actually handling reaction part. You see that I'm actually, again, doing the check. And the check is this way. The check, the first one, whether reaction has a reaction or not. If it's null, then I'm going to skip it. If it's not null, then I'm going to handle it. The second reactions should be object. The second one should be object. And within object, I'm expecting two things. One is the data and the tag. So I'm actually going to check reactions data is null. If it's not null, then the reaction data is this array. So I'm actually looking at this. Now I actually can find out whether my input is something really conform to the reaction JSON I'm actually expecting. If it's true, then I'm going to do the following case. Okay. So now I have this reaction. I actually know it's an array. Now you can see that I'm actually going to using your nice standard template as an array for vector. So just remind you what is the reaction looks like. Let's go to comment.h. As I said earlier, what's a reaction? Reaction is a standard template. This is the name of the template. This is the type of the template. And this is basically the declaration, the variable name to produce that instantiation of the template. That's what reactions is. Okay, so the first thing I'm going to do, you see that right now I'm actually going through the array. So the array, what I'm doing is I'm actually going through each of the element in the JSON object. So I create a loop, which is input JSON pointer reactions data from 0 to size. So this is the opportunity for us to learn a little bit about how do I use the vector template like an array. So the difference is that in the array, the C array, that the programmer need to know what is the range of the variable you need to put in. But in the template, the way we do it is actually we look at the template. What we did is you can say begin and the end. That's the template. Okay, we're doing this for C++ template array. You're using the function begin and the end to actually know what is the range, beginning and the end. So you don't have to worry about whether you miss one or add one or minus one or something like that. You use the begin and the end to actually handle that. And this array, on the other hand, is a JSON array. In the JSON array, if this is the array object, JSON will use the size. So this is interesting between this statement. I hope you won't confuse that this statement is iterate through the JSON array style. JSON array style from 0 to size parentheses, that's actually the JSON array. But this is the C++ vector array. That's actually doing this one. So this code actually show you, so it's a little bit complicated, but also you master like a 2 different world, and you'll be able to do a very powerful thing if you know the difference over there, okay? All right, so I'm actually going through with the JSON, going to each of the element in the JSON array object. And now what I did, you can see here, now what I did is I actually I used JDom again to create a reaction object. So essentially I'm going through that reaction I got from JSON. I turn one after the other into a reaction object. So that's why I use JDom again to create that object. And that object is called L reaction pointer. L stands for local variable. It's a reaction pointer after I do that. So after this 2 line, you actually create a reaction object, reaction C++ object based on that JSON you just extract from the line before. Okay, so now it's important for you to know. Remember, we always consider merge and the produce. Merge means that I want to merge a reaction into the existing reaction, existing comments that they already have a lot of reaction. So I need to check whether the reaction themselves is already exists. So what I did, you can see that I actually iterate through every single existing reaction. This part of the code is actually going through the reaction side, look at every single reaction and see if the person already provide a reaction. So essentially what we say, this is a semantic gap between JSON and C++, because in C++ world, we can actually define whether we allow a person to provide more than one reaction. So essentially this piece of code is actually assuming that if this person already reacted once, then I'm not going to allow you to reaction again. I do not. In this code, in fact, it doesn't even allow you to actually change your reaction. So that is a shortcoming about this implementation. But you can see that the same logic you can actually implement by changing this piece of code when you want to really build your own reaction object. You can actually change this piece of code to do things like, okay, I'm allowing one person to provide multiple reactions. You can have a conflicting reaction that's perfectly normal, or you can actually allow people to cancel a reaction, to delete a reaction, to add another reaction. That's also a perfectly viable option for you to actually implement. But the important thing is that we actually build in the concerns like this in the code of JDom when you try to merge the JSON world into the C++ world. Because in the JSON world, we try to be semantic-less. Means that they're just standard JSON object I can send to any place else. But when you actually convert it to a more processing under the context of a social media post, then essentially inside this point, you can actually implement your logic to do this one. Okay, so this is the part I actually checked, and you will actually, by the way, get this piece of code. So you can actually see my comment. And then if now is a question is that, hold on for a moment. So if this flag RT is a 0, what is a flag RT? So flag RT is being set here. If this is a duplicate reaction, we assume one person can only have a one reaction. That's an assumption. Then we actually set the RT flag is going to be 1. If the RT flag is not 1, then I'm going to push back this reaction into this reactions array. So now I'm actually adding that reaction into that. But if it's already duplicated, then that one won't be received. Okay, and if it's not, then I would just delete because that reaction is already duplicate. I want to clean the memory. By the way, there's also a very important check is that after I do new, I remember if I don't need this information, I'm actually going to clean it. Okay. And then I actually handle the tag the second. So essentially what there's one lesson I just remembered. It's very important. We have a new reaction coming in. So I create using JDom a C++ object represent reaction. And then I check whether the reaction is already there. If it's not, then I'm going to insert that reaction. So I'm actually grow my C++ object and to represent the merge content for both JSON, for both posts and the newer element together. So that's what we try to do. So what JDom is trying to do is doing the conversion of the JSON and also checking the semantic duplication. So it will work. I do want to say that at the end of my last example, I said the programmer has to be checked whether when you create malloc, you free. When you new, you will delete, right? Remember I say that. And that's very important because if you want to provide a service like what the typical today social media system, you're going to handle billions of objects, looks like this. And people is going to fly in the reaction. If you didn't handle the memory correctly, then essentially your malloc will quickly run out of memory. And when it ran out of memory, it's going to generate exception and the whole program crash. Of course, you actually have other ways to actually handle that. So, but the thing is that's why we're really careful as a C programmer, if you remember, that you want to make sure you don't have any memory leak. Okay, Java, Python programmer, you don't need to worry about that. But C++ programmer, you have to deal with this. Okay, so you remember that's my lesson number 1 to you. But my lesson number 2 to you before we finish this particular lecture is that as a C++ programmer, you actually have an alternative way to deal with memory leak issue. So let me just assume that your program will provide memory leak, but it will survive if you actually only have a 1 million object. Even though you're going to handle 1 billion objects, you only your memory is still big enough to handle 1 million. But you beyond 1 million, your program will crash. So how do I actually handle that? So the other way, this is what we call a quick, dirty way of handling things. I mean, sometimes you have to do this kind of thing as a programmer, but it's your choice whether you want to do the following way I'm saying. The way I will handle this is that from time to time, I'm going to do a dump J for every single one of objects in my system. So what do I mean by that is, okay, I'm actually going to have a memory leak. I know if I run more than 2 hours, I'm actually going to, my server will die. But what I did is every like 1 hour and 55 minutes, I'm going to do a dump J for every single object that I actually have. So after I do dump J, what do? I actually save it in the file system. So essentially, I have a 1 million object that in the file system. They're not using memory, they're using hard disk. They're actually using JSON format. And the JSON format is very compact. There's no memory leak when you go to the file. So then what I did, I killed my program. I just killed the program. If it has a memory leak, now after I kill the program, the memory go back to the operating system. And what I did next is that I'm actually going to restart the program fresh without any object. But then when you need an object, I will go to the file to do JDom, to actually bring the object back. But I don't have to bring all 1 million objects. If I bring 1 million objects back, I'm going to potentially have memory problem immediately anyway, even without memory leak. So I'm actually going to store all my objects in the JSON format in the file system. And only when I need it, I will actually retrieve it back. And that's what homework 7 is asked you to do, is do a search. So how do you actually build a program to find the right way? So let me actually tell you what it will look like before I let you go for the weekend. So if you go to my server, you see that I have a bunch of posts here. I actually save using dump.j to save each of the posts. So let's take a look at the post. Wait a minute, where I am at? Oh, 32.7. You can see that this is the post. By the way, this post is all generated by student last year. We actually really asked the student to actually implement this, and then as a team, just like what you will be doing, and they actually create a social interaction among themselves. So we're not using Facebook, we're using our own tool to be able to communicate with anything we want. And the only thing is that I actually have this thing called keyword, just like pretty much your search engine. You have your keyword, and essentially the rest is the same. Is basically the message and the post. And what we did is we actually not only store that, but we actually store the keywords. And for example, if I have a keyword called OK Kira, this is called index file. And inside the index file, you actually have a post ID. So it means that this particular post ID is actually has a keyword that's searchable using the keyword Kira. So what we did is, number one, we offload all the memory needs from our C++ program to the file system, which you probably know will trade off some performance because hard disk is slower, but we actually don't need to worry about our server will crash because everything being stored in the file. By the way, stored in the file is much better anyway. It's more persistent. It means that when you terminate your program, all the content will still be there. So what I did is somebody actually wanted to use the keyword Kira. I'm actually going to return this two object ID. And then each of the object ID, I actually just go to a different directory. That's what I have under the post directory. You actually can retrieve those posts. And then you actually do JDom again. Then I can actually convert that back to a C++ object, whatever I want to do. So I'm just closing this. Sorry, it's a 5 minutes extra. But I want to summarize is that this is the piece of code that for you to do this JSON world and C++ world conversion for a variety of reasons. You can think about a lot of today's modern services is basically just a more complicated version of what we just discussed, this lecture, number one. And number two, as a C++ programmer, you know that the memory is an issue. Segmentation fault, memory leak, those are the two most common nightmares for all the C programmer. I mean, if it's only 25 lines of code, you can deal with that. And what happens if this is a 1 million lines of code? Or like a Windows XP is 75 million lines of code. And how you're going to find out all the memory leak without the best tool that you can have. And one option is actually trying to do persistent. Try to move it to the file system, restart everything. It's not a silver bullet, but actually make your server run a little bit longer. Okay, all right, I'm going to close here, and I'm going back to academic search and make sure that you got help for homework 4. Yes. No, you don't need to submit a make file. You only need to submit the driver file. Yeah.